Hello once again, Mr. Wakefield here, and we're looking at section 8.4 now. These problems we're solving equations here in this section, no graphing like in the last section. We're just solving one variable equations, but these equations all look different, all right, all different kinds, but they do have one very important thing in common, and in that you can convert all of them to a quadratic equation, which we know how to solve quadratic equations now. How do we do this? All right. And by the way, just to make it clear so that when you see these directions on, say, a test question or something, when you see this thing where it says solve by making an appropriate substitution, that means that by using this thing we call an appropriate substitution, which I'll show you here coming up, it will then convert to a quadratic equation. Once it converts, then you can go from there. All right, so what we need to learn right now is how do we convert these things to quadratic equations by making that appropriate substitution. And I say the word appropriate because if you make if you make the wrong choice, something that's not the appropriate type of substitution, then it's not gonna work. Okay, so there's a certain strategy that we need to use in order to pick the right thing. What we ultimately want to do, as we see up here in the top paragraph, if you can make a substitution in an equation so that the resulting equation can be written in this form right here, you can see that this is a normal quadratic equation. It's just that u is the variable instead of x, okay? But otherwise, it looks like your normal quadratic equation, right? All right, the a, b, and c are the coefficients, all right? When you are able to convert the equation to this, then we say that the original equation is quadratic in form. In other words, the original equation is not a quadratic equation, but you can convert it to a quadratic equation that is in this form eventually. All right, and so we're going to talk about what all that means here coming up. But first of all, how do we find the appropriate substitution? Let's look at the first problem. And as I do that, I want you to notice something that is true with the typical quadratic equation, or not all of them, but certainly this type right here, where you got the u squared and the u and the no variable at all here and then the 0. Okay, what is true about that is that you have something here in the middle. It's the u, okay, not the bu, but just the u, all right? That is something that's in the middle of the problem that is being squared over here, isn't it? Okay, the u is here, and then the u is being squared there. I'm going to say that again because it's so important for this section. All right, you have something in the middle of the problem, u, that is being squared somewhere else, u squared. Okay, that is a common theme on all of these problems here, as you'll see coming up. So what I want you to do with that common theme is I want you to find something in this first problem that it's going to be in the middle of the problem usually. All right, we're not trying to trick you here. No, this is a new concept. All right, it's usually going to be in the middle of the problem. All right, in other words, we're not trying to like rearrange things on you to make it harder for you to find. It's usually going to be in the middle of the problem, and it's something that is being squared somewhere else in the problem. Okay, and it's something that has to have the variable, and otherwise it's not going to work. Isn't it true that if I pick this thing right here, not just the x, but the x squared, isn't it true? Let me write that down. Let's say that I want to make this u substitution. I want to make and your substitution will be equal to u. All right, that's why you're going to end up with u in your equation. But let's say that that's the thing that I pick to be my substitution. All right. Isn't it true that that thing right there is being squared here in the front? Isn't it true that if I square the u that I just picked, which is x squared, isn't it true that u squared is x squared squared? I mean, because in other words, I'm just squaring both sides right here. I'm squaring both sides of this new equation I just made. All right, u equal to x squared, u squared equal to this. But what is this? It's x to the 4th, which is right there in the front. This is what we're going to do on all of these problems, you guys. We're going to pick something that's in the middle, so that when you square it, square both sides right there, after you say u equal to that thing you picked, square both sides, it will then be equal to something that's in the front. And there it is right there. Now, because we did this, we can now make it look like this. All right. So make sure that it ends up looking like this and some other weird thing doesn't happen. All right. We still got to plug it. We still got to do our substitutions here in order to make that happen. Let me show you what I mean by that. What you do is you then replace the x squared with the u. And I replace whatever u squared ended up being equal to, which was the x to the fourth. So there's my x squared becoming the u right there. And then the x to the fourth becomes what? It becomes u squared because x to the fourth is equal to u squared. So you can replace it with that since it's equal to it. Okay? Let me zoom in there a little bit more. So the rest of the problem, other than the things that you replaced with the u and the u squared, other than that, everything else stays the same as it originally was. So the minus 9 is still there. The plus 20 is still there. And the equal to 0 is still there. Doesn't it now look like a normal quadratic equation because we did that? Doesn't it now look like this right here? Okay. And so because of that, we can now solve that quadratic equation. In this section, usually the factoring method will work. Okay, there's some other methods that we'll run into. But we know all the methods for solving a quadratic equation, so we're good. In fact, actually, let me take a look. Actually, the factoring method will work. On this part here where we're solving for u, the first part of the problem, there'll be a second part coming up. But on the first part, the factoring method will always work. Doesn't mean you have to do that. There's other methods that work even when the factoring method works, but you could do that on all of these. This ends up being the Berry method based on the way that it looks because you have all three terms here with the 0 on the other side. And that ends up being what? That ends up being... Isn't that negative 5 and negative 4? If you have 1 times 20 is 20. Okay, and we need two numbers that equal negative 9. Well, that would be negative 9 and negative 4, wouldn't it? I'm sorry, negative 5 and negative 4. The last step of the Berry method, it doesn't need to be done. So we set both of those factors equal to 0, just like we normally do in the factoring method. And our two answers are, and make some room here, this is just the first part of the problem. Okay, u equal to 5 and u equal to 4. You might be thinking, hey, wait a second, you just got the variable by itself. Aren't we done? I mean, you asked us to solve the equation. But here's the problem. The original equation has x in it. It does not have u in it. Okay, when whatever the original variable is, you guys, that's what you got to figure. That's what you got to get by itself. All right, that's what you got to figure out. Okay, the u is just going to help us get to that point. Okay, but we don't care what u is equal to ultimately. It's going to help us, but our ultimate goal is to figure out what the original variable, which is x, is equal to. So here's what you do. You now take these two things that I add up here in red. Okay, you take these two things and now you go backwards, and now you take the, remember how I replaced the x squared with u and the x to the fourth with u squared? Well, now I'm going to go backwards. I'm now going to take the u that I got in my answer, and I'm going to put the x squared back in there. So you start out by changing the x squared to a u. Now you change the u back to x squared again. And the reason why you do that is so that you can then solve for x now. But it's a lot easier to solve these two equations than the original equation. Okay, in fact, we haven't even talked about how to solve that. Okay, actually we have, but we're going to do it this way this time. But a lot of these other problems, there's no other way to solve it. Okay, other than to do this method normally. All right. And this method is easier than the methods that do exist in a lot of these problems. And that's why we learn this. All right. But so that's why we do it this way, is because these equations are going to be easier than to try to solve for x back here in the original problem. That's why we go through the whole u process right here with these steps with the u in it, even though the u eventually goes away. Anyway. These two equations here, these ones, you can't do the factoring method on both of these. On one of these you could, but I was talking about u earlier when I said you could always do the factory method. On the u part you can, but on the x part it just depends, all right? We're going to have a lot of different things come up here, and we'll go through all of them carefully. But on these two equations, can't you do the square root property? Because you have x squared by itself, and there's no variable on the other side on each of these two. And so because of that, I can say what? I can say x is equal to plus or minus square root of 5. And then this one is plus or minus square root of 4. But as I've said before, if your final answer has a radical with a perfect square, if it's a square root that is, if your final answer has a square root with a perfect square underneath it, don't just leave it like that. Okay. Actually evaluate it. So that's going to be plus or minus 2. So we actually have a total of 4 answers here now that I finally got x by itself. Total of 4 answers. Positive and negative square root of 5, and positive and negative 2. All right. So let's review here. Okay. You do the u substitution. You solve for u. And then after you solve for u, you then take what u was originally set equal to up here, your original substitution, and then you go backwards and you replace the u back with the original thing. All right. Let's do that again. Again, in this problem, you guys, is there something in the middle of the equation that when you square it, it's equal to something in the front of the equation? Isn't the bracket fit that description, you guys? Isn't it true that this bracket right here, I'll call it u again. Okay. That bracket, if I make that my u substitution, isn't it true that if I square both sides of that equation, all right, don't I get something that is in the front of the equation right here? Isn't u squared equal to this thing right here in the front? And so here's what you can do once again, just like in the last problem. You take the thing that you set equal to u and you replace it with u. Okay, so since u is equal to the bracket, I'm going to replace the bracket with u. And then whatever u squared ended up being equal to in the front of the problem, you take that whole thing that is equal to u squared and you replace it with u squared. And then just like in the last problem, the entire rest of the problem, other than the things that you replaced with u and u squared, everything else stays the same. So the minus that was in between, that stays the same. The equal to 6 at the end there, that stays the same. And once again, this is just a normal quadratic equation. Just your normal quadratic equation. All right. So how do we solve that then? Well, as we talked about, you guys, unless you're going to do the square root property, which is not a good idea here, because if you try to get the u squared by itself, then you would have a variable on the other side. So what we said was that if you're not going to do the square root property, try to move all the terms to one side. And if there's no parentheses getting in the way, just add or subtract the terms over. So subtract the 6 over here, in other words. And then try to factor. And yes, it will always work here. I already promised that. But in this section, it will. But when you're on the U step, anyway. But theoretically, if the factoring doesn't work, you can always do the quadratic formula as a fallback option, like we talked about at the end of section 8.2. The factoring does work, though, and I'm going to go ahead and do it because it does. The two numbers that I get, I need two numbers that add up to -1 in the middle, but they're factors of -6. They equal -6 when you multiply them. All right, and those numbers are -3 and +2. So what do I get here? I get u minus 3 is equal to 0, or u plus 2 is equal to 0. And then what two answers do I get? U is equal to 3 if I move the 3 over, and then u equal to -2 if I move the 2 over. Again, we are not solving for u ultimately. Yes, we do it on the first part of the problem, but that's just the beginning. What did we do in the last problem after I solved for u? I went back and I figured out what I looked at what u squared, or pardon me, u. I went back and I looked at what u was equal to, and I replaced the u with that. Just going backwards now. Originally, the bracket got replaced with u. Now the u is by itself. I'm going to replace the u back with the bracket again. Like this. And if the bracket is the only thing on that side of the equal sign, you don't need the bracket. All right? It's not being multiplied by anything or added to anything or anything. Okay? And so that's why you see that right there. Once again, I have a problem where I can do the square root property because I could get the x squared by itself right here. And I do know that this is a quadratic equation, all right, because you got polynomials on both sides here, all right, where x squared is the highest degree term. It's not just x, it's x squared. So I know that this is quadratic, both of these, and so that's why I'm trying to figure out. And it's not always going to be quadratic when you get to the final part here. The u part obviously will always be quadratic. That's why we said that it's going to be quadratic in form. All right, but this last part, you're going to get a different all different types of equations here coming up. On the final part here, you got to determine what your method is based on what you got. I'll help you out with that. All right, but this is definitely quadratic. So I am going to do the square root property again because I can get the x squared by itself without having a variable on the other side. I get x squared equal to 5 and x squared equal to 0. So just like the last problem, I've got x squared equal to a constant on both of these. So I do the same thing. I've got x is equal to plus or minus square root of 5. And I've got x is equal to plus or minus square root of 0. But what is the square root of 0? Okay, I could say plus or minus square root of 0, but like I said, if you get the square root of a number that is a perfect square, and 0 really is a perfect square, even though we don't usually mention it, because we know what you need to square to get 0. It's 0. Okay, so I could say plus or minus square root of 0 right here, but that is what? That's square root of 0 is 0. Okay, so we have plus or minus, in other words, positive or negative 0. What is positive or negative 0, though? Just to kind of condense down my answer here. What is positive or negative 0? It is, and let me just rewrite the whole thing here so I can have the entire answer together. That is the same thing as just 0 only, because positive and negative 0 are the same number. 0. Okay? So plus or minus 0 is just one number, 0. And so we really only have 3 answers there, even though it looked like it was going to be 4, because the plus or minus 0 was just one number. Okay, let's do that one more time here. I'll let you guys try some after that. This right here, again, I'm picking something in the middle of the problem that has a variable in it, that when I square it, it's going to be something that's in the front of the problem. If you're wondering why I picked that, okay, let's talk about let's actually see what happens when I square it. Okay, so my u is going to be this red box here again, x to the 1/2. Okay, what happens if I square both sides of the equation? All right. You don't need to put a bracket around the u like we usually do when we square both sides, because it's not going to be any different, but please put a bracket over here just to make sure that it sets itself up correctly. And by doing that, we can see that we have a variable, an exponent on the inside, and an exponent on the outside. As we've seen many times when it's set up like that, variable and exponent on the inside and an exponent on the outside, you multiply the exponents to figure out what that's equal to. But 1/2 times 2 is 1/2 times 2 is equal to 1, isn't it? Okay. It's just 1 over 1, which is 1. So that means the exponent is 1. So you end up with x to the first, which is x. And sure enough, there it is right there in the front. X is in the front. So you square the u that you chose, and it ends up being equal to something in the front. So once again, you replace the thing that you chose with u. You take whatever u squared, what ended up being equal to, and you replace that with u squared, since it's equal to u squared. And everything else stays the same. Everything else stays the same. like this. Okay. And we got ourselves a normal quadratic equation once again. Okay, it's in the normal form where, because I got the 0 on one side and the other side looks like a normal Berry method setup. What two numbers can I do for the Berry method here? I need two numbers that equal 8 when I multiply them, but they need to add up to -6. So wouldn't these be the numbers right here? Let me write those down. U minus 4 and U minus 2. And so I get U minus 4 equal to 0, and I get U minus 2 equal to 0. That gives me what two answers here? 4 and 2 when I move the 4 and the 2 over to the other side. Once again, I have now solved for U. But that's just halfway. That's just halfway through the problem now. What's the other half? Okay. You take the thing that U is equal to and you put it back in. Okay. But before I do that, though, isn't x to the 1/2 the same thing as square root of x? And the reason why I say that is because we're not used to having fraction exponents inside of an equation, are we? Okay, but we are used to having radicals inside of equations. We learned how to solve radical equations at the end of chapter 7. So it would just be easier, since they're the same thing anyway, instead of putting the x to the 1/2 in the place of u like you normally would, take what is just the same thing as x to the 1/2 and put that in there instead. Like this. Just put the square root of x in there. All right. Because I would have to convert it to square root of x anyway, because again, I'm not used to having x to the 1/2 in my equation. All right. And so I don't know how to deal with that, but I do know how to deal with radical equations. And so put the radical in there instead. What do I do, you guys, when I have a radical equation and the radical is by itself? I square both sides, don't I? Putting brackets around that. Just like we did back in section 7.6, like that. What do we get? X is equal to 16. X is equal to 4. By the way, you guys, remember when you solve a radical equation, you need to check your answers. Okay, but let me just tell you right now, in one of these problems, one of these U problems that we're doing, and I don't know how deeply I mentioned this back in 7.6, but let me make it clear now. The reason why sometimes you get some bad answers when you solve a radical equation is because sometimes squaring both sides leads to an issue. It leads to something that was supposed to be the wrong answer, and it disguises itself as being the right answer. That's why you check your answers when you have a radical equation in the first place. My point is this, you guys. You don't have to go back to the original equation all the time when you solve a radical equation and you square both sides. You just have to go back to any equation that you had before you square both sides and check that one. Okay? But it's got to be an equation that has x in it, not u, because x and u are not the same thing. Okay? And I need to check these two x numbers. These are not u numbers. So you can go back to where it says square root of x equal to 4 and square root of x equal to 2. You can check those two numbers, or check those two equations, because before you square both sides, those were equations that had x in it. But since you hadn't, let me just rewrite them down here again off to the side. Actually, I'll write it down here. Square root of x equal to 4, square root of x equal to 2. This is what they looked like before you squared both sides, right? As long as you plug it into an equation that has the same variable in it, and it's an equation that you had before you square both sides, that will then tell you whether or not it's an okay answer. Again, we got to do that kind of stuff when we solve a radical equation, in particular one that has a square root radical. If I plug 16 into this, that's true. If I plug 4 into this one, remember, this answer came from this equation, and this answer came from this equation. All right, so you don't need to you don't need to check the 4 over with this one or the 16 over with this one. You just got to go back to the equation it came from before you squared both sides. These are both true, aren't they? Okay. If this had been a negative 4 here, it wouldn't be true because radical 16 is equal to positive 4 only. Okay, but these are both true. And so these are both good. But whenever you square both sides while you're solving an equation, all right, you got to check your answers. That's why we checked our answers in that radical equation section. All right. So what we have now, you guys, and you can see that number 1 is very similar where it has the square root of x, and then if you square it, it's going to be equal to x, all right? Number 2 is very similar to problem B right above it with the bracket in the middle there. Okay, that's something to consider as well. On the back, though, it gets a little more interesting. Okay, we've talked about this right here is the same thing as the cube root of x. So keep that in mind. Cube root of x. So you could probably tell here that that should be your u substitution right there in the middle. I'll let you try it, though. And then over here, this one is something we've never seen before. The u is actually going to be x to the negative 1. Because when you square it, it'll be equal to x to the negative 2. But what happens when you end up plugging x to the negative 1 back in at the end of the problem? How do you solve an equation that has a negative exponent in it? We haven't seen that before. The way to do that is by converting x to the negative 1 to 1 over x and then solving, because we know how to solve an equation that has a fraction in it, but we don't know how to solve an equation with a negative exponent in it. So change the negative exponent to this. Remember, x to the negative 1 is the same thing as 1 over x to the positive 1. We talked about that in chapter 1 with the exponent rules. Okay, section 1.6. All right. And so do that at the end of the problem, and that'll help you solve it. So a little bit of, wanted to give you some clues there so you don't get stuck. But otherwise, please try problems 1 through 4 and hit the play button after that, and we'll take a look at the answers. Okay, so let's take a look at number 1 here, and you can see here that we have something that's in the middle that when you square it, when you say u is equal to that thing, square root of x, if you square both sides there of that equation, you end up getting u squared equal to x, which again is something that's in the front. And so sure enough, when you then take, like we've been doing, when you take that thing that was equal to u, replace it with u, and then you take what u squared was equal to and you replace that with u squared, keeping everything else the same, the plus, the minus 6, the equal to 0. You take all that and you keep it, you keep that the same. It ends up looking like a normal quadratic equation. We then solve that equation using the Berry method here because it's set up like a Berry method situation. Solving that, I get 2 answers here, negative 3 and 2. I then, like I always do after I solve for u, I then go back and I replace the u with a square root of x, because that's what u is equal to in this problem. There it is right there. Square root of x, I know it's hard to see that because I squared both sides on the same step there, like we normally do. But that's what it looked like before I squared both sides. Right there. I then squared both sides after that. Okay. So in other words, yeah, I replaced the u with square root of x. All right. The negative 3 and the 2 are obviously still there. Then I square both sides after that. And then that gave me what? That gave me 9 and 4. But why did I cross out the 9 after I scored both sides and I got 9 and 4? Like I told you guys, whenever you score both sides, look back at any equation with the same variable in it, which is x here. And we're checking x numbers here, not u numbers, 9 and 4. You don't need to check the u numbers. When we go back and check the answers here for 9 and 4, we got to go back to an equation with the same variable in it that was an equation before we squared both sides. So these 2 equations were what we had just before we squared both sides. If I plug in 9 into this one and 4 into this one, This one's bad, isn't it? Let me show you that. If we plug that in there, I get something that's false because the square root radical is equal to the positive answer only, as we learned in chapter 7. The square root radical, if it's equal to anything, it's going to be equal to the positive number. So that's a bad answer, but this one is good. So you cross out the bad one, you keep the good one. All right. So that's number 1. Number 2. All right, again, we got something in the middle that when you square it, you get something that's in the front. So you replace the you replace those two things with u and u squared like we've been doing, and we got ourselves a normal quadratic equation there. Solve it using the factoring method, which we can do in these problems, on the u part that is, and we end up getting 8 and 3. All right. Plug back in the bracket. You don't need to keep the bracket if that's the only thing on that side of the equal sign, but replace the u with the bracket, or at least the inside of the bracket. All right, because again, you don't need the bracket. This gives you 2 brand new quadratic equations, but this time they have x in it. So I then solve those quadratic equations. And again, why are they quadratic, you guys? It's because both sides are polynomials. Okay. You don't have like fractions with variables in the bottom or radicals with variables in it. So those are the types of things that would not be a polynomial equation, a polynomial on both sides. But if you've got a polynomial on both sides, then if the highest exponent of the variable, okay, assuming you're solving a one variable equation, which we are, there's no second one, the highest exponent is 2, again, that's quadratic, okay? So we know, and we're not going to be told that. That's why I was making sure we remember what makes it quadratic. We're not going to be told that this is quadratic. You got to be able to know that in the middle of the problem here and be able to then say, okay, I know it's quadratic. How do I solve it? What method do I use? Since we can't do the square root property here, because then that would mean that the x would have to be moved over to the other side. That's not going to work. I'm going to try to do the factoring method here and see what happens. And as it turns out, the factoring method does work, okay? And then we set each one of those things equal to 0 right there, and we get what you see right there, 4 different answers, okay? Flipping over to the back side, we got a couple more problems back here, as we already talked about. X negative 1 in the middle there, that's a good choice for u, because when you square that u, you get x to the negative 2. Remember, if you have a variable, an exponent, and then outside the bracket another exponent, you multiply those exponents, and that's why you get x negative 2, which is in the front here. Remember, the 20 is separate from that. This is the u squared is only equal to x negative 2. There's no 20 there. So the 20 is separate from the u squared. You just replace the x negative 2 with the u squared. All right, like I said, after you replace whatever u is equal to with after you replace whatever u is equal to with u, and then after you replace whatever u to the negative 2 is equal to with u to the my bad, I said that wrong again. After you replace the x negative 2, which is what u squared was equal to, after you replace it with u to the second power, okay, then everything else stays the same in the problem. And so that's why the 20 still has to be here, the plus 9 has to be here, plus 1 and equals 0, that's all still there. I just want to make sure, because we haven't seen a number in front of the u squared yet. This is the first time. Okay, the 20 is still there, you guys. It is just the x negative 2 that was equal to u squared. All right. And so we then solve that doing the Berry method. I know that 1 times 20 is 20. The two numbers have to add up to 9, so 4 and 5 will work, won't they? So I put those in there with the 20u and the 20u. I got to do the last step of the Berry method. Doing that, factoring a 4 out of the first bracket and a 5 out of the second bracket, I get these two brackets as a result. So now I'm done factoring. I set both of those factors equal to 0. I then get these two answers right here, negative 1/5 and negative 1/4. As always, after I solve for u, I then what? I then take what u was equal to, which is x negative 1, and I put that back in the place of u. But as I told you guys, hey, well, what do we do when we have a negative exponent in an equation? We what? We replace that with the fraction equivalent. So x negative 1 would be 1 over x to the first. I did that same thing over here. And what's good about that is I can now cross multiply because both sides of the equation are just single fractions, and as we've talked about before, you can cross multiply in that case. Just so long as the negative sign is not outside the fraction, or that's not allowed. You got to move it in if it's outside. All right. And since this is just a single term up here, you can move it in there. All right, that's okay. There's not going to be an issue with that. I then cross multiply. I get these two equations right here. I then divide out the negative 1 to get the x by itself, and I end up with negative 5 and negative 4. Now, we did just solve a fraction equation, remember. So when you solve fraction equations, you do need to check your answers to make sure that they don't make the denominator equal to 0. Okay, since negative 5 came from this equation, you don't need to you don't need to check it with this one. You just need to check negative 5 with what it came from, and you just need to check negative 4 with where it came from. All right, and you end up getting it ends up being okay, because when you plug in the negative 5 and the negative 4 into these two spots respectively, it doesn't make the denominator equal to 0. It just makes it equal to itself. Negative 5 here and negative 4 here. And so you're fine. But I'm just reminding you that anytime you solve an equation with a fraction, you got to do that. Okay, so that's number 3. Number 4. Okay. Again, there's something in the middle so that when you square it, it's equal to something that's in the front, x to the 2/3. 1/3 times 2 is 2/3. All right, and that's why it ends up matching up with this. So again, we got ourselves a normal quadratic equation. We do the Berry method, we solve that. We get negative 3 and 1 down here. But our goal is not to solve for u ultimately, it's to solve for x. So we take the what u is equal to, which is x to the 1/3, and we replace it with that. But again, we're not used to having fraction exponents in an equation, so make sure to change it to a radical when you do that. We know from section 7.2 that 1/3 means cube root of x, if the x is the base there, okay? 1/3 means the cube root of whatever that thing was that was taken to the 1/3 power. And so that's x, and that's why x goes in there, okay? So we take that and we replace it with that. Okay, and so and again, I did 2 steps in one right there. So let me just show you how that comes out. It comes out like this. All right, like that. So you're converting the 1/3 to the cube root of x. Then you realize that, oh, hey, this is one of those problems where it's a radical equation. And not only is it a radical equation, but it's one of those well, just like any radical equation, you need to get the radical by itself. So I've got a radical equation, the radical is by itself. That means that I can not square both sides this time because it's not a square root radical, but because it's a cube root radical that's by itself, I cube both sides. All right, and I got these two answers right here. You do not need to check your answers when you cube both sides, just when you square both sides. Remember, we talked about that. Okay, so just when you square both sides. So those are the answers. No, it's not mandatory to check that. All right, so that concludes this section on solving by making an appropriate substitution. Okay, remember, ultimately you are solving for the original variable. When you solve for u, you're just halfway through the problem at that point. I see a lot of students that they'll solve for u and then they'll stop. Okay, just make sure to remember you got to take it all the way and solve for the original variable. All right, otherwise let me know if you have any questions about section 8.4. You enjoy your day and take care.